Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to take a look at rational inequalities where we're comparing a rational expression like 3 over x plus 5 to a non-zero number like 2. What's different here than the last video I did when that number was a 0, I cannot find critical values, I cannot test any intervals until I'm comparing to 0. So what I need to do first is subtract over the 2 to the left-hand side. So 3 over x plus 5, all minus 2 is greater than 0. I need a common denominator to combine these into one rational expression, one fraction. And so I can multiply 2 numerator and denominator by x plus 5. That gives me a common denominator and it will let me combine the two numerators together. Multiplying by x plus 5 over x plus 5 is the same as multiplying by 1. So nothing changes, but it puts it in a form where I can get these two fractions together, these two expressions together into one rational expression, one algebraic fraction. So in the numerator, I'm going to have 3, and then I'm going to distribute negative 2 into the parentheses. Negative 2 times x is negative 2x. Negative 2 times 5, that's negative 10. And this is all over x plus 5, still greater than 0. Simplifying the numerator, I get negative 2x. 3 minus 10 is negative 7. Still over x plus 5, greater than 0. Now I've got it ready to go. Now it looks like one of the problems from the last video. The numerator, we've got a little work to do to find that critical value that comes from there. We need to set negative 2x minus 7 equal to 0, or negative 2x equal to 7. Divide through by negative 2, and that's going to be negative 7 halves, negative 3.5, in between negative 3 and negative 4. The critical value from the denominator is negative 5. I take a look at the sign in the inequality. There's no equal sign, so that means neither critical value is included. On a number line, there's 0. Negative 5 is one of our critical values, and negative 7 halves, which is between negative 4 and negative 3. So that breaks the number line into 3 intervals. The test point from the first interval to the left of negative 5, I'm going to use negative 6. For the second one, between negative 5 and negative 7 halves, I'm going to use negative 4. And then from the third interval, I'm going to use 0. We could just substitute in and see if it works. I'm going to still try the sign chart approach. So my test points are negative 6, negative 4, and 0. My two expressions are negative 2x minus 7 and x plus 5. I'm looking for that to be greater than 0, so I'm looking for positive numbers. That first factor is a little harder to work with all the negative 2x in front of it, but we can still do it. Negative 2 times negative 6 is positive 12. And 12 minus 7, that's going to be positive. Negative 6 plus 5 is negative 1, and so that's negative. And that means that we have a fraction where we have a positive numerator, a negative denominator. That's a negative fraction, and it's not greater than 0. So negative 6 is not a solution. Let's try negative 4. Negative 2 times negative 4 is positive 8, so we've got 8 minus 7, that's positive. Negative 4 plus 5, that's also positive. So we've got a positive number divided by a positive number. That's a positive result. Negative 4 is a solution, and we can shade in between those two endpoints. Now if we plug in 0, negative 2 times 0 minus 7, that's negative. 0 plus 5 is positive. So we've got a negative number divided by a positive number. That's negative, not a solution. And so the only solutions that we have are between -5 and -7 halves. We use parentheses because there was no equal sign, so no critical values are included. So on the number line, it goes between -5 and -7/2. Let's see if this actually is a solution. So I'm going to plug the -4 back into the original inequality. That would be 3 over -4 plus 5. Is that greater than 2? Well, that denominator, -4 plus 5, is +1. So we've got 3 over 1, which is 3, and that is greater than 2. So that value did work. If we had substituted 0, we would have had 3/5. That's not greater than 2. If we had put in -6, we would have had 3 over -1. -3, not greater than 2. So you could have also gone back to the original inequality and checked them there. Let me show you. Let me write all of that out. So again, we had 3 over x plus 5 greater than 2. And there were 3 test points that we wanted to check. -6 would have given us 3 over -6 plus 5, which is 3 over -1, which is -3, and that is not greater than 2. 0 would have given us, I'm sorry, that wasn't the next one. -4 was next. 3 over -4 plus 5 was 3 over 1, or +3. That is greater than 2, so that was a solution. And 0, we would have had 3 over 0 plus 5, which is just 3/5, and that is not greater than 2. So either way, we see that -4 is a solution. That means everything in that one interval is a solution as well. Okay, one more problem to go, pretty similar. I've got 6x plus 1 over 2x minus 3 being less than 4. I want to begin by subtracting over the 4. Oops. 6x plus 1 over 2x minus 3 minus 4 is less than 0. And I've left myself a little space to put in a factor of 2x minus 3 over 2x minus 3. That's going to give me a common denominator to combine the left side into a single algebraic fraction. So the left side is going to be 6x plus 1. Distribute the -4. -4 times 2x is minus 8x. -4 times -3, that's plus 12. And that's all going to be over 2x minus 3 being less than 0. Simplify the numerator, and we've got -2x, 6x minus 8x, and plus 13, 1 plus 12, over 2x minus 3 less than 0. The first critical number coming from the numerator is where -2x is equal to -13. Dividing through by -2, that's x equals 13/2, which on a number line is at 6.5, between 6 and 7. For the denominator, 2x minus 3 equals 0 will turn into 2x is equal to 3. Divide both sides by 2 and we get x equals 3/2, or 1.5. So on a number line, those are both positive. So I'm going to put my 0 over to the left. 1, 2, 3, 4, 5, 6, 7. Once was at 1.5, and one was at 6.5. And there I have my 3 intervals. So the test point from the first interval, I'm going to go with 0. The second interval between 1.5 and 6.5, I can use any of those numbers. I'm just going to use the smallest one, which is 2. And to the right of 6.5, 7. So those are my test points. Now I have some options. Again, I can come back to the last fraction I had. I can use a sign chart. I'm going to try just substituting into the original inequality here. So I'm going to start with x equals 0, that first interval, and that's the easiest one to work out. When I plug in 0 on the left-hand side of, again, my original inequality, 6x plus 1 over 2x minus 3 is less than 4. The numerator and denominator, the parts with x disappear, and I'm left with negative 1/3. 1 over negative 3 is negative 1/3. Is that less than 4? It is. So 0 is a solution. And so that means everything from that first interval is a solution. I shade that on the number line. Next, I want to go to x equals 2. And I've got 6 times 2 plus 1 over 2 times 2 minus 3. That is 13 in the numerator and 1 in the denominator. That's just 13. Is that less than 4? No. So that's not a solution. And that means none of the values in that middle interval are solutions either. I'm going to check x equals 7 last. Substitute in 7, I get 6 times 7 plus 1 over 2 times 7 minus 3. This one's a little more challenging. The numerator is 43. The denominator is 11. Now I can divide this on my calculator and get a decimal. I'm going to think of this as a mixed number though. 11 goes into 43 3 times with 10 left over. 3 and 10 over 11. Is that less than 4? It is. And so 7 is a solution, and everything in that far right interval is as well. So our solutions are to the left of 3/2, 1.5, and to the right of 13/2, or 6.5. So I'm going to write this down at the bottom left. Parentheses, negative infinity, comma, 3/2, parentheses. That's the first interval. U for union, parentheses. That 6.5 number, that was 13/2, comma, infinity. Parentheses around both of those as well. I could have substituted into the second inequality. I could have done it by plugging them in. I could have done it by making a sign chart. Really, like, you have some flexibility here. Try to pick the way that works best for you. That's it for this section. I will see you in the next section, which is the last section of chapter 1 in this course.